Yeah, I mean, thanks for joining me on this long weekend. Our
Well,
very very sunny. Just kidding, Vancouver weather here. Oh, wait, you're on the East Coast, was it?
no, I'm actually yeah, I'm actually
You're on
on
the
the
East
East
Coast,
Coast.
yeah. Okay,
So,
cool. So maybe the weather's better where you are, but over here it's not too great today.
oh, that's brutal.
Yeah. Anyways, yeah. So today we've got three sessions followed by a resume review at the end. First session here, I have Robert with me, and we'll be going through mock system design question. We'll have another system design after that, and then following a leak code. So thanks for joining, everyone.
Sounds
Robert,
good.
why don't you go ahead and give a quick introduction?
Yeah, sure. Thanks, Leo. Yeah, so my name's Robert. Currently just about to graduate from Carleton University here in Ottawa, and I have a fairly strong security background, I find.
Mm-hmm.
So most of my previous work terms have been involved in security companies, be that with software development, penetration testing, or being a security analyst. So that's kind of what I'm kind of looking to get into. So more on the security side of software engineering, and I figured I'd do a system design to kind of brush up my skills on that because I haven't actually done a system design interview
Cool. Yeah.
over the course of my co-ops. So we'll see how this goes.
Awesome for sure. So let's just quickly introduce the kind of session. So we're going to have about a 1 hour session, which is usually what will be the case for system designs. Now, obviously, in a real design interview,
Right.
right, we'll have usually 5 minutes at the start for introductions, 5 minutes at the end for just wrap up questions. Um, we don't really need to do that kind of formality, so we can just kind of hop right in, right, and then we'll leave 5-10 minutes at the
Fair
end just
enough.
for feedback as well as any questions you have about the actual the question or about feedback for you as an interviewer. Okay.
Sounds
I
good.
mean, without further ado, I think we just get right into it. Honestly, there's no need to stall. Great.
Absolutely.
So for
Let's
today's
do it.
problem, we're going to be designing GitHub. Okay. So GitHub, we're
Oh
not
boy.
actually doing the full feature set. That's just kind of the mindset we're going to be in. Okay. So the features that we got to support on GitHub is that a user has to be able to, upload code and download code, right? So like push pull, right? And just to be clear here, we don't need to actually write any code here. We don't need to do that kind of stuff. We're just sketching out a high level, connections for various systems that you want to be able to, talk about, right? So
Okay.
this is within a user; they have to be able to push and pull code, okay? And then I want to also support functionality of collaboration, right? So this is the reason that we want to use GitHub and not just local Git, is that we want other people to also be able to to upload and download code, right? And a bit
Okay.
more granularity on this is that we don't want anyone to be able to push or pull code, right? So we want to be able to add and remove users from a repository, right? So we need to have a bit of a security touch to this per se. So this is a
Okay.
high level
Cool.
function that we need to support for our version of GitHub.
Okay. So that's all right. Um, with regards to collaboration, I guess yeah. So we'd have like multiple people per repository. Do we need to worry about like issues or pull requests, anything like that? Like what are we looking for on that
No, we
front?
won't be worrying too much about the Git process. This is essential. So we don't
Okay.
really care about this like GitHub or anything like this, right? We're kind of using GitHub just as the metaphor per se. So this is just going to be, if you
Okay.
think of
Cool.
this, it doesn't be code in general. It could be files for all we care about, but code is just like what we want to talk
Right.
about,
Right.
right?
Right.
So yeah, again, right. So we have repositories, right? And so you in this case you might be creating a repository, right? And of course you would be the owner or you would be a user on it, right? And then, of course, we need to
Yep.
be able to add and remove users in this context to repositories, and then upload, download
Hmm.
code for a repository. Yes.
Okay. Cool. So repository. Cool. So I'll go through the entities. Functional requirements seem fairly straightforward. Just upload, download, and then add and remove users. So the entities, we're probably going to. So we're going to need the repository. We're going to need the user, and we're going to need some degree of files within that repository, I imagine.
Hmm.
Um,
So repository will
and
be, so we'll
then
just define
so
a repository as a set of files. Yes, that's correct. Yeah.
Yeah, that makes sense. So files, and then the specific. I imagine there would probably be like a many. No, no, it would be. No, this would actually be a foreign key schema in the database. So title, description, um, and then authorized users. And then we could probably go more granular with permissions and whatnot if we wanted to down the line.
Hmm.
Um,
We
So
can always keep it higher level than you might end up with, and just move on, just to kind of get
right,
a
for sure.
picture. But yeah,
Cool. File name, contents. All right, let's talk about non-functional requirements. What are we focusing on here? I imagine. So I imagine we're gonna be more focused on availability and consistency.
availability and consistency. I definitely agree, and I want to just be explicit here. I want one of the key components for consistency being that a user cannot download or upload code if they are not a collaborator, right?
Okay.
And what I mean by that is
Load
that
code.
once that relationship changes at all, that must be consistent.
Cool. All right. Um. All right. I imagine scalability is also going to be something we're going to need to worry about, especially considering we're doing collaboration, a bunch of people working from around the world, open source contributions, all that fun stuff.
Mm-hmm.
Um, now, as far as user counts go, what are we looking? Where are we looking at on that front?
We don't need to worry too much about the login and sign up part of that. So that's not going to
Okay.
be.
No, sorry. Like how many
Oh, okay.
like active users do we have? Sorry, I should have
Oh,
been
okay.
more
Talking about
explicit on that.
numbers. Yeah. So so we'll say that we have about 1 million active daily users.
Okay. Million daily active
Yeah.
users. Um, okay. What kind of activities are we looking at in terms of like read
Yeah.
write?
So we can assume that each one of these people, on average, uploads once and downloads once a day.
Once and downloads once per day. Uh, when we say upload, is that like one file or one repository?
So we'll say it cannot be on average, one. We can say half of a repository. So they might, be editing half of the files in a repository per day. Yeah.
Okay. The repo. And then, okay, so I know GitHub has like a cap on repositories of 1 GB. So let's say average repo size is 500 megs.
Yeah,
How's that
that sounds
sound?
fine. Yeah.
Cool. All right. Um, so we got 1 million daily active users. So we've got everybody uploading and downloading once per day, roughly half the repo, so about 250 megs. Okay. How are we looking on in terms of the requirements? Is there anything I'm missing?
Nothing explicit, but I will say that this is going to be like you said, it's open source. It's free, it's off. Well, not necessarily open source, but because these kind of environments, we're going to be this will be a global kind of entity. So your users for a repository will be all around the world, which is
Okay.
I want to point that out.
So users are going to be global.
Yeah, and that's global per
That's going to be
repository
good
as
to know.
well. So not just global per like GitHub, just global per repository. Yeah, that's right.
Global okay, so what are the implications of that then?
Yeah, so for example,
In
it wouldn't
terms
be
of
practical for you to have a repository only available in a certain region. It has
okay, so no regional locked repositories.
Yes, it has to support. Well, you can have it in a region, but it also has to be available in other regions. Yes.
Right. Yeah. Okay, that makes sense. Okay. Cool. And then we'll probably just have like the now we'll have the username be the email, which is also primary key. Um, and then we can have whatever kind of additional data on the user that we want. Files, the name, the contents. We can probably also have like a hash of the file just to make sure that things are consistent. Okay, so we're gonna upload, we're gonna download. Okay, let's talk. I'm gonna just talk, throw down an API real quick as well.
Sure.
So we're gonna want get, so Tory, and then I guess whatever kind of name we want. Um, and that'll probably just like clone the entire, that'll probably just get the entire repo.
Okay.
Thinking we also want to get repositories. is then path to a file. So this will be getting a specific file. Post repositories. So this will be kind of creating a repo. Oh, sorry,
Okay.
wait, okay. Do we need to worry about creating and like managing repositories?
I mean, we don't need to talk about that flow as much. The biggest, like the flow we'll be talking about primarily will be the uploading and downloading code and the collaboration part. So adding removing users for a repository. But I mean, you can still
Okay,
outline the
cool.
the API shape for creating a repository. We just won't be drilling into that at all.
Okay, cool. So I'll just, yeah, post repositories. So also do a put. This is a little bit more chaotic because I'm just kind of like
Okay,
spitballing thoughts
sure.
as I go here. Um, so this will be updating user, or no, so this would be updating repo details, and then if we want to put the repositories name users or collaborators or what have you, then we'd be looking at, so this would allow us to kind of like update active users. Could also probably do like a post or put just for different functionalities, but functionally they're doing the same thing. We'll also have a delete endpoint for that same thing. Okay,
So just to be clear,
and
so
then
your post and put is only for adding collaborators.
no, so this is kind of like just generally okay, yeah, I guess I should make that a little bit more clear. So post um, users, I guess yeah, let's just call that users. So this will be adding collaborators, and then I guess name. Oh no, wait. Yeah, username would be the email. No, that would be annoying in a URL. So let's actually. I literally just remember that. Um, if we use the email as the as like the email, sorry, if we use the email as the username, we run into a situation where if you try to put that in a URL,
Yeah.
it just won't really work too well.
I suppose you
Um,
can escape
and
it
then
though,
I guess we
right?
could fold.
I
Sorry?
suppose you can escape the character, like the.
You could, but I think it's a little easier to just kind of like have the two separate things. Plus it allows people to kind of like have a separate GitHub like a GitHub air quotes
Sure.
username.
So the primary key
Um,
is what then?
Primary key would probably, if I had to hazard guess, it would actually probably be the email, and then no, wait, the email that's for login. Let's keep the username to the primary key,
Cool.
which like this is kind of like a weird like a an abnormal case because normally you would want to use the email as a primary key, but here you'd probably want to actually have the username because oh no, wait. The way I have it, that makes actually no sense because then you're having because I don't have it specified in the. Okay, wait. Yeah, no, I realize where I
We
went wrong
can
here.
we can have a unique. I mean, you have repository IDs, right? We can have a user
That's
ID
true.
as well then.
Yeah, that makes sense. Yeah, I honestly I usually cheat with IDs as primary keys, so that makes sense. And then we'll probably also just have like an ID here. Like it technically it works, and then but yeah, it does work. It's not quite as like true to how databases work in terms of being able to have primary keys relevant to the data, but we don't really care. Okay. So
Okay.
All right.
And so how would your API look for the add and remove users, collaborators?
Yeah, so basically what we would have is the post here would give us so we had its repository's name, and so we just kind of like add in probably like some user details, and then we would also be able to add on to that, tacking on, permissions or what have you. Um, and then the updating, so this would probably be um, you know, if we ever need to update permissions on them or anything, or actually, I guess this doesn't even matter because like we're not worried about permissions right now, so we can probably just save that for later. So post and delete for now, and then here we'll have the username because that'll actually distinguish where that, or no, actually user ID. There we go.
Okay.
That'll do it. Um, Now upload, download. We're also going to want to oh, guess, no, wait. Okay, now I'm seeing where we're running into some issues here because I think we need a way to actually upload the code. Um, so the code itself would probably best go into, so this is where we're actually creating the repository,
Yep.
and then updating the repo details. I feel like, you know what, we could probably just like, this is probably where we would add and remove files or add files.
Okay. Okay. Sure.
Or no,
We could do it that way.
no,
I mean, it's bit. So you have get here, for getting a file.
yeah. So yeah, no, I think
So you can just do the opposite of that
let
would.
me just make one quick edit. Yeah, because what I'm thinking is we have um, a get and a post for the um, files themselves. So like we post to the repository files, and then the get request is the file path. Like I'm trying to make this more of like a REST API.
Sure. Okay.
Um, yeah. Okay. So I think that's where we're at. What do we think about this?
Yeah. Okay. Um, there were gets. Yeah. I mean, I think the API is fine. I don't want to spend too much time on the API.
That's fair. Yeah.
I want to get to actually talking more
The system
about the
design.
system.
Okay.
So
Right.
let's leave the API here for now. We can come back to it if we find it's an issue later on.
Makes sense. All right. So first things first, we obviously have our lovely little web interface here. Just gonna. So I imagine we're going to want a web interface so that people can actually interact with it.
Sure. I mean
We'll just.
that's not actually too important in this context. The main
Oh, okay.
interaction is going to
So do we?
be from two clients.
Okay. So we can probably just actually um, change that to some kind of client. Doesn't really matter what it is.
Yeah. So we can
Um,
have just for the hat we can just kind of outline. It depends on how you want to lead this, but we can say to start we can have a client who creates a repository and uploads and downloads
okay.
code to it. So there's no collaboration yet. So you can walk.
Yeah, there's no collab.
Yeah.
Yeah.
So you can kind of walk me through what systems that kind of flow would touch.
Yeah, cool. So if we're looking for upload and download files, I imagine we're going to want some kind of object. So for files, we're going to want some kind of object storage. Actually, wait, what Zoom level are you at right now?
I can
Let's see if
follow
it's
you
staying.
around actually, so it's not an issue. Yeah.
Okay, cool. So if we're looking at um, files, so we're going to want some kind of object storage for files. Users, we're probably going to want database table for those, and then so, and then we're also going to want so users, repository, stories are probably going to be in some kind of database tables, files. So reasoning here is that for the file, so the actual like file
Right.
contents are probably going to go into the object storage, and then those can probably have their own metadata. What we're concerned about is mostly, I guess, so we wouldn't actually have the contents in here. What we would probably do is we would have the ID, the name, and the hash in the actual database table, and the object storage would contain the
Okay.
rest. As far as this goes, yeah, so obviously now that I mentioned that, we're gonna need some kind of a database. We'll just black box that for now. And then we're also going to want, all right, so I'm thinking, probably be beneficial to have, so we know we have creation, we have updates, and we have deletion. So since we're just worried about the code right now, we can probably just do upload and download services. So um, like a read write service type of deal. And we'd have, okay, yeah, read service, and then I guess upload service. Okay, the database, and then there's an S3 bucket somewhere in there. So yeah, let's just go generic to object storage.
Okay, that's fine.
Doesn't really matter what it is, as long as, yeah, so as long as we can. Oh, I almost forgot. Need to tie the files to a repository. That would do it. Okay. So we have the object storage, we have the database. So the database contains the intel on where the actual files are going to be located. Okay. And then, I guess for this, I'll clarify that we have a relational database because we actually do have like like an actual defined set of relations between our data.
Okay.
As far as, I don't think we care really about metadata in files, do we?
No, that wouldn't matter in this context. No.
That wouldn't matter? Okay, cool. So we can just stick to having a relational database because that'll allow us to have a much stronger structure. And then again, we're kind of black boxing this database, so we'll worry about availability, consistency, and scaling a little bit later. So as far as this goes, we can probably set something up so that we obviously run kind of an, so we have the actual API itself. Can probably chuck a load balancer on that later, and then that is going. So client makes a request to the API. And can I attach these? Okay, I think those should be attached. Yeah, there we go. And then based on whether or not we need to create or retrieve files, then we make separate services for each. And then, see here. So imagine if we're making something like GitHub, we're just worried about code, right? We're not worried about like versioning well, I guess we are probably worried about
We don't need
versioning.
to worry about versioning too much right now. We can revisit that
Okay,
later. So right now it's just
cool.
like, yeah, you can imagine it without versioning for now. Yeah, that's right.
Okay, so we're dealing with no versioning. Cool. So we have a read service and an upload service. So, okay. So, let's double check a few things here. So the upload service would probably go into object storage, and then, okay. So if we're thinking about this, so the read service would probably go through to the relational database and then to object storage to retrieve the files as we need them. So if we think about this way, so we kind of go one, so this is kind of like step
Yeah.
one in the read, and then two in the write. or sorry, we grab the database. So if we're ever reading information, um, be it data on a file. Oh, okay. Now I'm realizing something else. We need a way to map the file path to the actual ID. So what I'm thinking is, in that case, we'd probably just have the actual path.
I kind of imagine the name being the path of the file.
Oh, so you were thinking the name was the path. Okay, that actually makes a lot of sense. You know what? I like that. Okay, contains file path. That actually works for me. Cool. And then from here, our upload service is a very similar thing. Go into the relational database, um, do its thing. Oh, no, wait. Okay. So for the upload service, it's a little bit different because if the upload service fails, right,
Mm-hmm.
if the uploading, oh, no, I'm realizing what I could do here. So we actually have two upload, I guess. Yeah, so creation service, and then so let's call this two things. So we've got the creation service, which is actually going to deal with how the data interacts with the repository, and then what we'll do is we'll also have a separate uploader service. So what this will do is this will make sure that, first of all, the data actually gets uploaded first. So we make sure that the data gets uploaded, and then we update our database, which also contains how it interacts with which also contains, the relations between the users, um, the repositories, all that
This
sort of
is
stuff.
for the this is for which path? The upload, like creating. This is for creating a repository or uploading files, or which path are you talking about right now?
Yeah, so this would be for upload. This would be for uploading
Right. So
files.
for uploading files, you're saying that we want to update. We want the creation service to to hand the file off to the uploader service first, and then wait
Yep.
for the uploader service to finish, or what?
Yeah, so we'd wait for the uploader service to finish. Um, oh, wait. Okay. Now I'm seeing where the bottleneck here is, because if that upload is slower, then we might run into a bit of a situation. So what we could do, I'm thinking on that front, we might want to have like some kind of a message queue to make sure that, okay, so the uploader service works. Okay, you know what? It sounds like I feel like I'm probably over engineering this before I have the functional requirements in place.
That's up to you. I mean, we can go with this for now if you think that there's a lot more to talk about, and
Okay.
revisit this after. That's also fine. But I just want to
Okay.
just be
Yeah.
explicit here that you're saying that this is one, right? This is two, and then over here this is three, right?
Yeah. This would be three. That's
Where's
correct. Yeah.
my hockey?
That's
Okay.
yeah.
Okay.
Yeah. That was kind of what I was aiming for. So yeah. So we have the creation service, and then that goes into an uploader service, which actually does the upload. Once that's done, creation service gets alerted somehow, probably through a message queue, and then we update the actual relational database itself.
Okay. We can go with this for now, and we'll come
Um,
back to that.
Sounds good. Next, we'll probably also need an update service. Oh, no, okay, wait. I don't know what this could be. We'll call this the file service, because this is going to be specifically for dealing with files. And then
What's the
with
distinction
regards
between
to,
the file service and the uploader service?
so the file service is just kind of like it's kind of, I guess this would be like a wrapper on the upload, like around the actual upload, and then the actually updating the data in the database.
Okay.
So it kind of just fires off across to say, hey, uploader service, can you get this file into the object storage for me? Upload service does its thing. Once that's successful, file service comes back and updates the
Okay.
database.
Okay. Sure.
Um, and so the read service is a little bit simpler. It just looks through the database to figure out what goes where, and then we're also going to need
is this read
store
service
and
is
link.
only for files as well, or is it reading all data?
So this would, I guess, be for all data. I guess step 2 would be
Okay,
optional
yeah, that's
if you
fine.
need to retrieve a file. And then we could probably split that off as late as necessary
Okay,
later on. And then from there, we're also going to have a. This is getting big. We'll also probably have a service that just deals with. Um, we'll just have a repository service, which which mostly deals with the actual repositories. And yeah, okay, just organize this a little bit. Okay, there we go. And I'll just patch that here. Okay, cool. Okay, so the repository service that's going to handle our actual. So that's going to handle all the things relating to repositories specifically. Think about it in terms of the API. So we have the repository service that's going to be dealing um, the overall repository, and then if we need to deal with files, with the file routes, then we go with the actual file service, and then that handles that. Okay, and then delete. So that's mostly going to be handled by the repositories. Okay, how are we looking at this
okay,
one?
yeah, I can see all the paths are more or less covered, so I'm okay with that. Just to confirm again, right? So the repository service in this context would be handling the adding of collaborators,
Yeah, so that would be handling
adding and removing,
adding any kind of collaborators. Yeah,
adding and removing. Okay, and
yeah,
right,
adding and
and
removing. Yeah.
this database, um, one of the tables here will, so one of the tables here being the repository table, I presume, will contain the
Right.
list of
Yep.
authorized users.
Yeah, so I mean, obviously, in an actual SQL
Right.
database, you'd probably have like a many-to-many
Okay.
table, but I don't think we want to go quite
Sure.
that
Okay.
granular. Because I imagine, one repository is going to have multiple possible authorized
Yep.
users, and then, you know, one user is probably going to be on many repositories, especially if this is global.
Yes. Okay.
All right.
Yeah, that's fine. That's fine for now. So let's introduce the second client now, right? So our client one here, let's say let's client one. So our client one here is the
Okay.
owner of repository one, and now they're adding our client two to this to be a collaborator on this repository. All right.
Oh, okay. There. That was weird on my screen for a second. Okay, so we got client two. So actually, to make this a little bit more clear, I guess. So let's call this guy the owner, and this one the collaborator,
Sure. Yeah.
just for the sake of clarity. Okay, they're funneling through the API.
Yes. So
All right.
now, so now the collaborator wants to also write to this repository. So can you walk me through the flow here?
Yeah, so it's in terms of the owner. So let's say the owner wants to actually add this collaborator onto the repository, because obviously if the collaborator, you know, isn't actually in the repository, if they're not in the authorized users, then if they try to read anything, if they try to grab anything, they won't be able to do jack. So that's uh, so that's going to be that. Now, the owner would need to go through the API. They need to go through the repository service
Mm-hmm.
to actually add the user into add the collaborator into the database,
Okay.
or sorry, add the collaborator to the repository's authorized users. Um, and then from there, their collaborator should be able to do whatever writes they're authorized. The primary thing I imagine the collaborator would not be able to do would be to modify the actual repository
Mm-hmm.
itself. So the collaborator wouldn't necessarily be able to go through and so let's say um, the authorized users. Yeah, I guess we need to
Yeah, we
probably
don't
have
need to worry too
some
much
data here.
about the like a realistic permissions
Yeah,
model.
permissions or whatnot.
Yeah,
Yeah,
I'm just looking at the
yeah,
read path or read and write path here just for we can assume everyone's not malicious just for the sake of argument for now, And
Okay,
in the
well
happy
that
path, what would the owner do? What will be touched by the owner? And after that is achieved, what would
okay,
be touched by the collaborator?
that makes sense. Okay, yeah, sorry, security brain already going
That's
into
okay.
threat modeling
Yeah.
and stuff. So, all right, so yeah, in terms of adding a collaborator, so owner goes through the API, they go through the repository service, that updates the database, and then we're golden.
Okay.
Uh, then from there, the collaborator can go through and run their whatever reads they need. So if they're needing to just grab their data on the repository, then they can go through the database on
Would
that
that need to
front.
go to the repository service as well? The collaborator on the read path.
Oh, that's actually a good point. Um, yeah, you know what? Um, in that case, yeah. So the collaborator. So if they're reading from the repository, oh, okay, I can see how I kind of borked this, but that's fine. Um, so yeah, if they're going to just download files, they'd go through the read service. Yeah, because I explicitly mentioned a second ago that they wouldn't be able to modify their repository. Yeah, so they'd go through the read service, and then retrieve whatever files they may, whatever data they may need. So if it's a list of files in the repository, they'd be able to do that. And then from there, they can also go in. Then from there, they'd also be able to retrieve the files from object storage if need
Right.
be.
So in this case, the read service would be responsible for getting this repositories item from this user, right? And
Yep.
then using that logic to figure out if it has permission to read the object storage.
Yeah, that
Okay.
would be it. Yeah.
Okay. And how about the write path?
So the right path, again, so fairly similar
Yeah.
thing. So you'd be going through the collaborator. Um, First thing you need to do is actually go through the read service to verify that, or no. What you need to do is you go through the API, you go through the file service. This does a check to make sure that, okay, collaborator is in the right repository that we're looking at.
Yeah.
Um, and then from there, if we're doing an upload, then we'd be able to go through that whole path
Right.
there.
Okay. It also sounds like if you want to talk a bit about security right now, right? So our APIs is and we have these endpoints, right? So let's say that
Yep.
we're the collaborator right now. Our client is a collaborator, and we are trying to do. Let me just quickly look at this. Let me try to say we're trying to do post repository files. So like we're trying to add files or like edit files, right?
Yeah.
So in this case, let's say this repository. So now we're so first of all, yeah, that was a good example. So that's great. Now we are no longer saying that everyone's happy. We're saying some people could be malicious. So we do need to consider security now, right? So in this
Right.
context, where the collaborator is not a collaborator on the repository, because you're using repository name, right? So
Yep.
oh, cool. So you have repository names or IDs, whatnot, and that could be public. Because for example, this collaborator might have previously been a collaborator, now they're not, right? So they know the ID of the
Right.
repository, and now they're trying to post a file. So can you tell me at what step would they be rejected?
They would probably be rejected right here at the file service because that's where the check happened. Or wait, okay, never mind. I see where the problem is here. Okay, all right. So yeah, okay, I realize my error here. So okay, we would need to. Okay, let's be a little bit more explicit in what kind of steps I'm taking here. Um, so I guess we could add in like an auth check here.
Okay.
Then, if the auth check passes, um, uh, then we delegate the uploading to the uploader service. Then we upload the file itself. Once the file is uploaded successfully, we update the database.
Okay. So the file service in this
Okay.
context would be doing authentication first and then deciding to proceed.
Yes,
Okay, and okay,
that's
and
correct.
how about the same person who's not a collaborator anymore? They're trying to do a get file.
Yep. So we could actually just implement the auth check right around the time they're actually in the database, hitting the database. So um, in this case, when they actually try to go through the read service and then they'd hit the database, if we do an auth, if we basically like do an auth check on which files they can
Right.
access, um, then it's going to come back negative, and then that would fail right around here.
Okay. So in other
So
words,
before they ever
all
get,
the different paths need
yeah,
to do the auth check.
so they would need to do an auth check. I guess it would make sense to have like an authorization service or an auth service, but I guess like that's not really a feature here. That's not really a hard non-functional requirement.
Right. Okay. I think
Um,
that's fair. I think that's a fair
but
balance. Okay.
yeah, yeah, sorry. Um, to address availability and consistency
Yeah.
here, I think for the object storage, that's going to be externally managed, so we don't need to necessarily worry about that. Relational database is probably where we're going to need more consistency here. So I'm thinking we could probably shard the information based on. So I'm thinking, just kind of
Sure.
spitballing here.
So we're talking about availability right now, right?
Yeah, availability slash I guess consistency. Yeah, so we actually already talked about that. So the collaborator, so we already have. Oh yeah, no, we did have that as a requirement. That makes sense. Okay, so database availability, right? So if we have some stuff here. So for availability, I think what would make sense here is because we're on a repo by repo basis,
Mm-hmm.
what will probably make sense is to have some level of sharding as opposed to replicas. Because if we do a replica, that's going to replicate the entire database, and that's not necessarily what we want.
Yeah.
So I'm thinking we do horizontal sharding based on the repository.
Okay.
Oh, actually, would that be too
Is this
granular?
is this
Because
sharding the which like what are you sharding like which table? This is just the repository table.
yeah, so I think in terms of oh no wait yeah no that's gonna be on a per table basis. You're right. That
Like
makes sense.
you
Okay.
could shard a database based on some criteria, right? So you could shard tables independently. If you're referring to an ID of a table, then it has to shard the table, right? So maybe I should ask you which of these tables you have of, or it might not be a table, but like which component of the database is the part you're concerned about in
Yeah,
terms
I'm
of availability.
yeah. Well, I think the main thing is going to be files, because that's kind of what we're dealing with the most here,
Okay.
right? We're not gonna have people, like constantly like if we're doing like everyone uploading and downloading files once a day, they're not necessarily like modifying the repository.
Yeah.
They're going to be working with the
Yeah.
files, right? So they're dealing with like half the repo here, right? So we're probably going to want to have some level of the horizontal sharding on the files. The main issue with that, however, and now that I think about this, the main issue with that is that we may run into, you know, essentially merge conflicts, right? Where, somebody uploads right as somebody is downloading, and then there's some stuff there.
Mm-hmm.
So I think
Well, that would be more for consistency and not availability, right?
that's true, right? So yeah. So I think for in terms of availability, horizontal sharding on the files table based on the repository.
It's good you're
And then
talking
I
about
and
merge conflicts, right? This is basically one of the things
yeah,
about the consistency part.
yeah. So, we'll base that on repository, and we don't necessarily want to have like per repository because you could have like one repository with like a single file, and that would kind of be a waste of a shard. So I'm thinking we could probably have like a range of IDs
Okay.
that we would
Yeah.
have like say some like every 500 repo IDs, for instance. Um, we basically create a new shard.
Sure.
The details of that I'm not entirely familiar with on how we
Okay.
do
No,
that.
that's fine.
So
That's fine. Yeah. Yeah. That level of granularity is fine. Fine for this purpose. Um,
cool.
I did want to talk a little bit. So, I mean, like, would you prefer? We have time for about one more question here. Because I want to dive a bit deeper on this.
Sure.
Would you prefer to talk about consistency or scalability?
So consistency, this is in terms of, so we've already addressed the concern about, whether or not
Yeah,
the fact that they can't download or upload code if they aren't a
yeah, I'm happy
collaborator.
with that. But there's one more aspect about consistency, which is about file consistency. So we can talk a
Right.
bit about that if you're interested.
You know what? Let's talk about that because
Sure.
I do kind of want to see if I can.
Yeah.
I'd love to do both, but I think availability that kind of like focuses on scalability, and then this should. I feel like this works decently well for scaling, but we can talk about that more later in feedback.
Yeah, sure.
Um,
Consistency. So I wanted to
all
start the
right.
conversation up by just saying, right now with your writing. So again, now we have no longer, so we have no more malicious people, right? So we're just talking about the consistency aspect. So we have a
Right.
collaborator. They're updating a file. So they'll go from. So I'm gonna put my pen here. They go from the API. They'll go to the file service. They have permission, right? So they have permission. We
Hmm.
authenticate. That's fine. And then we want to
Yep.
upload. So this guy puts a file over here, and let's say it's a big file, right? So
Yep.
so we're just chilling on this, like we're waiting on this connection, right? And
Yep.
then another guy comes along while that's like, so while this is happening, right? So let's say right now this is t equals 1, okay? So another t
Yep.
equals 1, another guy comes in, they say, okay, I want to write, I have permission, now I'm uploading to the same file, right? So
Right.
this first upload
Okay.
is taking t equals 1, let's say it takes t equal to 10, right? And the second guy comes in at t
Yeah.
equals 2, and that guy finishes at t equals 12,
12.
right?
Right.
So can you tell me what would happen in this case, and how is that, if that's an issue, how we can think about addressing that?
Okay. So I think the main thing here is if you're uploading the same file, right?
Yeah,
So when you say the same file, how is it the same, right?
sure.
Is it like the same file path? Is it the same contents? Because those might be like two completely different
Well, yeah. Well, the
approaches
same
there.
same file in this case just means it's the same path, and uh, yeah,
Same
and
path,
well,
different
the
content.
contents might not be different, but you wouldn't know. Like each person wouldn't know if they're different or not.
That's true. Okay, fair enough. Okay, so let's say just path collisions for the
Sure.
sake of this. So this is kind of where. So one aspect of this is obviously if the contents are the same, right? If the contents are identical, then we don't even necessarily need to start the upload because what can happen, I
But how would you know if
guess,
they're identical?
is file hash. We have access to a file hash in the uploader surface, and this is actually kind of what I was thinking about earlier with potentially adding in a message queue, right? So
So just to clarify that, so the uploader service has data
right,
about the file hashes. Is that just stored in the memory of the uploader service?
yeah, well, it wouldn't necessarily be because then we'd need then we'd run into issues with that. Uh, that said, there are a couple of approaches we could take to this. Approach number one is we have like a message queue that actually contains the nope, wait, that wouldn't work because it's a queue, so that's just more for scheduling things. So approach number two, that would probably be more along the lines of having some kind of like a cache where let's get a cache going here. So if we have a cache, then what we can do is we can essentially say, hey, um, based on the file hash, right?
Mm-hmm.
So we take the file, we go into the uploader service. Um, the uploader service would probably compute some kind of hash of the file.
Okay.
And let's just say, for the sake of example, SHA-256 Blake 2B doesn't matter. Um, so we compute a file hash here, and then we also would probably send that back here as a response, but that's not necessarily a major concern right now. What is a concern is that when we compute the file hash, that goes into here in the cache, and what that would do is I would say, okay, so hash, and then I guess last uploaded, right? So
Okay.
what this will do, so we have this item in our cache here, and then if the two items have the same file hash, right? So I guess we could probably make a key of like um, file path and then file hash, right? And then if this key is already in the cache, right?
Yeah.
Then what we can do is we can say, oh, well, shoot, um, we have a problem here because they're they're the same file essentially going into the same path. We can't have that. So what we do instead of just going straight to upload is we go into the cache. Then if the cache doesn't return that we have conflict the same files, then we go in here. And then so we actually do the upload, and then we actually do,
Okay.
and then update is step 6 here.
So, okay, cool. But this isn't so. I sort of see how this solves the consistency aspect
It
on
solves the
the
identical file problem, and I recognize that it does not solve the not identical file
right.
problem,
Okay.
and that's item number 2. So,
Well, let's spend
okay,
let's spend a quick minute on this one. If you can think of an intuitive solution, we can talk about it. If you don't, let's move on to uh, the next part because this is
okay.
the next because yeah, that's a non.
We're actually pretty close
Yeah,
to time, are we
we
not?
have 10 minutes, so we're
Okay, we have 10 minutes. Okay,
but we probably want to spend quite a couple minutes on the feedback. So if
yeah,
you
no,
don't
that's what
have
I
an
was
intuitive
thinking.
answer to this one, we can just move on.
Yeah, I'm thinking. What probably makes sense is okay. So if we have a message queue, that would probably suggest that okay, um, file upload is complete. Um, I guess what we could do is actually do 2 database hits, right? So we might what we might be able to do is in this. So this might need a message queue component. But what I'm thinking here
Okay.
is this is getting
You can
very
just you
chaotic,
can
but
just you can just kind of draw the shorthand here. I just want to get the feel for your intuition. Um,
yeah. So current
yeah.
intuition is whenever we kind of go into whenever we send things off to a to the uploader queue, what we want is when the uploader queue is like finished,
Yeah.
right? So when the uploader queue is finished, we have some kind of like a message queue here or like somewhere along the process. Oh my God, this is not cooperating with me here. So we have a message queue somewhere in the process, and then once the uploader is done with that, it actually fires off a message into the message queue, and the file service is checking for that. So what essentially is happening is when you try to upload a file, you go through the API, you go through the file service, blah 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 blah. You do the auth check. At the same time, once the auth check completes, you actually you actually update the entry for the file accordingly, whether this is updating the file itself or creating a new file. This also helps if in the event that you try to post a file that already exists, which would probably just throw an error response. But then you update, you add an entry, and then each entry has a flag as to whether it's being updated.
Okay.
So what we can do in that case is say, hey, this file is being updated. And then if anyone else tries to update that same file, then in the time, so like between, what was it, like t equals, I think you had a thing here
Yeah.
at some point, but yeah, you had like t equals 0 and then t equals 10 and then t equals 2 and t equals 12. So so if anybody tries to upload a file, so if you try to upload a file between t equals 0 and t equals 10, and that flag is not going to get processed, right? So we're still gonna be uploading as far as the database is concerned. Once that message that I'm done comes back, file service goes through, uh, pulls from the message queue, and then it updates the database when it's done. So this also kind of solves like, hey, how do we know when the file is
Okay.
done?
Okay.
And then yeah, that'll update that flag.
Okay. I think I see intuition there. So I think that would work in that context, but we can talk about why that wouldn't be ideal either. Um, All right,
That's fair.
cool.
Yeah. No, I
Sounds
yeah.
good. Yeah, yeah.
All right.
We'll call the mock here. And I
Okay.
wanted to.
Sorry. Yeah. Why am I
No,
apologizing?
I mean you did pretty good. So don't worry, don't need to apologize or anything. Let's spend a bit of time here. 5 minutes or so. Give us some feedback on the situation, and
Sounds good.
we can and open up for questions as well afterwards. So
Absolutely. Yeah.
let's just talk high level first. So aside from the design, I think the process was pretty clear, right? Not too much to say there. I think you've definitely seen some past ones, and some past ones where it goes to the functional, non-functional, some common objects, API sketch. One thing I will say about this is that if I were you, it's good to kind of ask early on what the focus of the interview would be on. So, for example, are we focusing specifically on, like as an example, oops, that's a wrong marker. Um, we listed these non-functional requirements, but you'll notice that most of the time you won't actually get to optimize your design for any one of them, right? And so I would say at the
Really.
beginning I would ask like, hey, which of these function requirements or non-functional requirements should we be focusing on? Because
Okay.
if you don't go in with a focus and you're just going for just a design, you'll spend a lot of time afterwards trying to make it work in one of these things. So it's better to just ask up front which of these you should keep in mind, like keep on top of your mind. And
Okay. So
yeah,
so it sounds like it's best to just kind of like, hey, which of these do we want to prioritize the
that's right.
most in terms of like what you want for the
Yes.
service? Okay, that makes
Otherwise,
sense.
if you go with too much of a generalist design, you don't hit any of the points, then you're
Right.
kind of
Yeah,
leaving
that
it
makes
up
sense.
to the interviewer's interpretation.
Okay. Yeah, that makes
And
sense.
and the next thing is like yeah, so the API design I think we spent too much time on. This is really not
Yeah,
relevant,
no, that
right?
was
Like
yeah, that was entirely I realized that going into it I was like, or sorry, coming out of it I was just like, oh shoot, we're already at like, what was it? Like
yeah,
125 on your
yeah.
end?
So it's not
Um
right. Like another thing is like for example, you can say that, hey, I want to talk about the API shape here. How important would this be? And it's not important.
okay.
Just don't spend too much time on it. Right now, if they're talking a lot about
Okay.
it, then first you should ask yourselves, oh, okay, is there a specific one we want to focus on? Right. If there's not, then they're probably a bad interviewer. But like you don't have a choice, right? So in general, you
That's
want to go
fair.
in and have an expectation for how long you want to spend on this thing because you spent too long on the API, and you'll notice that it didn't
Yeah,
really even
definitely.
matter at the end
Yeah.
because regardless of what you actually wrote down in the API part, there still is two reads, right? There's read write for the file and read write for collaborators, right? That's it, right? Like that's kind of the situation, and so
Okay, so it sounds like
yeah,
sorry to cut you off. It sounds like in terms of just like API, we could probably just generalize it to um um so let's say we have a read, write, and then entity. And then right, if we only have and so this would kind of just abstract away having to deal with REST
yes,
specifically.
yes, because
Um
the rest doesn't matter here.
it like
That's
it,
right.
it
Yeah.
yeah, okay. So I guess just having this more abstract API kind of
Yeah,
like
just
format
just
that's
ask, hey, is the API going to be focused here? Are you okay if I keep it high level? Okay,
okay,
because
cool.
most of the
That
time,
makes sense.
especially for new grad, this part just doesn't matter at all. This is basically, do you know
Right,
what needs
yeah.
to be written and read? Okay, now if the
Okay,
yeah,
that makes sense.
yeah, don't spend time on that. Now let's talk about the actual design here.
Cool.
I'm gonna blitz through this a little bit, okay, and you let me know if any part's a bit confusing here. The first
Sure.
part is that it is correct, right? So it's correct in that there won't be a correctness issue here. The only thing was at the end when you identified that there's no feedback currently for ongoing uploads, right? And so
Yeah.
that is actually that's actually a general pattern, right? The pattern here that you need to recognize is one action takes a long time, and I don't want a conflicting one to happen at the same time, right? In this case, it's
Right.
uploading a large file. In some other cases, it could be a slow read, a slow write. In some other cases, it could be a long network delay. Other cases, it could be you're going to a different client and they need to perform a calculation, right? So this is a general pattern: is you're doing a long thing and you don't want other people to do it while you are doing it. Okay, how do you prevent
Yeah.
that? One way, so the way you set here is okay. I'll also break it down a little bit. There's the pre API and the post API part. Okay, so I'm talking about only the
Yeah.
post API part. So in this context,
Right.
uh, using the queue in this context would be one way to force it to be compatible, right? And you might know this in the
Mhm.
context of, for example, GitHub, which has what's called a merge queue. So I don't know if you use GitHub or whatever, but GitHub has a merge queue where all of the ongoing merges are lined up in literally a queue. and then merge the head, and then merge the next, and merge the next, right? And so, you didn't have to, well, you don't have to know that, right? You just know that helps. But the idea here
Right.
is that you can actually just have a queue of these deltas coming in, right? And so you don't really need a quote unquote file service here. You can have like a push service. You have an actual distributed queue here that has a bunch, and you can shard these based on the repository, right? So you have a bunch of these
Oh,
guys.
okay, that's interesting.
Each queue at the head. So this is the head. Okay, this is the head side. This is the head side. Right. This is the head side. You have one delta. Right. One get like a diff. Right. You have one delta coming in.
Yeah.
The uploader service computes the diff and uploads it. And then when this is done, it does two things. First of all, this is what you just said at the end, right? Goes back, just goes directly to the database, updates the hash, pops the next head off, and then does the same thing, right? So that's the first way that
Right,
you can
right,
do
right.
it with literally a queue. The other way is like with, the other way is with this older technology known as file locking, right? So object
Okay.
storages such as S3, all of them essentially have file locks, which is that if you acquire a lock on the file, no one else can write to it. In fact, you can have it to be even more strict where no one can read to it. That's one aspect which you actually did not cover here, which would be a follow up, which is that in your current system, before you said that you can have a flag on files, which is that if
Right.
someone reads a file, they don't know if that's the latest version. Right now, if you're reading a file with a flag on it, then you would know that it's the latest version. However, that would still present a scalability concern because
Right. Yeah, that's
now when you
the
read a repository, you have to
thing.
go
Yeah.
to the not only have to go to the object store, but you would have to read the files table for every single file in the repository,
Yeah.
right? So
Okay.
there's a trade-off there which was not explicitly mentioned. I'm not sure aware of that one, so just be aware of that. A bit more
Fair
on the
enough.
read
Okay.
path. So that is one concern regarding the trade-off between consistency and scalability. Um, in general, about object stores in this context for read is that generally speaking, it's not always ideal to have to go through your own API to read metadata and then to read the object storage because that adds two
Right.
levels of latency, right? There's latency from your ping because you have ping here, right? Like you have ping here, and you
Right.
have ping here,
Yep.
right? This you can assume is all on your computers. There's no ping there, right? But there's two pings here, which is not great. Now latency is not a consideration here, but in general, you should be considering aspects where you can give someone an authorization key. So for example, the owner as a user, as a collaborator, right? Owner goes
Right.
here, repository service, but I forgot the order here. Doesn't really matter, right? It generates a key, which is made available to this collaborator, right? And the collaborator updates
Okay.
their metadata. So, for example, when they first pull or whatnot, goes to the API, says, "Hey, do you have a key waiting for me? Oh, you have a key waiting for me. Let me get this key." Now this guy has a key which they can use directly to read the object store, right?
You know what would be even quicker
Mm-hmm.
probably because I there's also like the notion of like signing and verifying
Yes.
keys, right? So like if we have so if we have like a public-private key system, like this would probably be like an attack on feature, but if you just have like a private
Yes.
key that you can use to like verify your identity and say to the service like, hey, I have this thing, and then maybe go through that. I don't know that's something that might factor in. I'm not sure. Actually, now
Yeah.
you mentioned that, because you do have like the authorization keys in the database. So I'm thinking about like, okay, would it make more sense to just have like a public-private key
Yeah,
pair
definitely. Yeah, you could
collaborate
definitely do
and
public-private keys. Right, and
yeah,
if you're security focused, that's definitely something you could be talking about a lot more in terms of this because, right,
for
if you
sure.
can because keep in mind, right, your limiting factor for this service that you've just sketched is that
Yeah,
all the bandwidth goes through your servers, and that is really not ideal, right? You want to
right.
minimize the
Yeah,
bandwidth of your servers, and so what you actually want for both a read and upload, for both a read and write path. I'm just demonstrating this on a read path, is to give someone an authorization to read directly from the object store, and then this is their bandwidth,
yeah.
right? This is not your bandwidth over here.
Right. Okay. Yeah. That actually makes a lot of sense. And then I guess you would also have like this
Yeah,
path
you
here
would
from
have
the
that.
owners.
So the only time that would
Okay.
happen, the
Right.
only bandwidth you would consume is you would go to here to get the key, and then you would come back.
Get the key, and then everything else from there is just like, oh, you you have the whatchamacallit. You have the clients going directly to the object storage as opposed to pinging the API and then
Correct.
going
Yeah.
to the
And
object
similar on the
storage.
right path, you would go to here, you would get a key, lock the file as needed, right? And then you would return the key back, okay? So that you would
And then
this
the
would go
key
upload over here,
goes to
and then
yeah.
when this is
Okay,
done, you send a second request, like a second request over or whatnot. Or it could be,
okay,
if you don't want to do two requests, you can then schedule. So you get the key, right? Then at this time you start uploading your file because you have permission now, and then your file server
right,
spins off a checker to check when this file's finished updating.
right. Okay, that makes a lot of sense. Okay, I can see. Yeah, I can see how that would work like a lot better than what I had in mind. Um, yeah,
Yep.
no, that I like
Cool.
that approach. Okay, I'll definitely keep that in my back pocket for if I ever have to do
Yeah,
this
for
again.
sure. Cool.
Oh,
I'll give we have a couple minutes here. I just want to give you a chance to ask any questions about either what you've done today or just about the question in general, and then we'll move on to the next candidate. So
yeah, sure. So I think yeah, obviously, I mean, this is gonna be recorded, so I'll probably be able to see my see where I can improve, and then you also had some notes on the end. I think if you had to give like what I think if you had to boil it down, what would you say would be one thing that I should, that's like a strength,
right,
and then
yeah.
one thing that I could probably work on just explicitly for the
I
future.
think the strength here is that you were able to pretty quickly iterate on a design that you could justify pretty quickly, right? This
Hmm.
at least gives you a platform to kind of then address further questions on, right? So that part's good.
Right.
And so at that point, I think the main thing to work on is just time control, right? Time control in two contexts. The
Time
first
control.
time control is in the context of the process, so knowing what parts to spend more time on, which parts to spend less time on, right? That's how you can push and pull your priority system. Whereas in this case, you spent too much time on the REST API design. You could have spent more time building your platform out, and then you would have had a chance to answer one more question from me, essentially, right? That's
Right. What was right? That okay, that makes sense. And then what was that one last question going to be? Sorry to cut you
So the
off.
first question was about the consistency, which was about how do you know a file won't be overwritten, right? So that's the one you
Right.
answered. The second one would have been what is the current bottleneck of the system, which is that you're using your own bandwidth to upload and read files.
Right. And then yeah, and then we have the and then we have that to go
Yep.
over. Okay, that makes sense. Cool. All right. So awesome. So just getting a design out there, and so I feel like those. It sounds like those are kind of tied together because you know, like getting a design out
Yeah.
there, but also just not having enough time to kind of iterate on it. So I think it sounds like it's good to just kind of make sure I know A, what the interviewer wants me to focus on
Yes.
going
Yes.
forward, and then B, um, use that to kind of like figure out, okay, where do I want to spend my
Yes,
time?
I want to iterate like that. Your design is correct in the sense that it would have worked, right? So that's distinct from design that
Right.
would not produce a correct answer, right? And so at this point, it's a matter of time, right? So it's correct. Okay,
Yeah.
that's great. But then there's obviously follow up questions that you need to anticipate first of all. But that comes from experience. So there's follow up questions generally
Of course.
always.
Yeah.
And so the more time you give yourself to do that, the better, generally speaking, right?
Makes sense.
So I wouldn't like
Cool.
so the takeaway for you I would say is like practice the time control and practice banging out designs even faster. And then separately from that, you can anticipate the kind of questions that would come up. But don't conflate the two. Because they're
Okay.
two separate skills. Yes.
Right. Yeah, that makes sense. So I guess yeah, just for like if I ever have a system design interview coming up, just like like figure out okay, I have this system here. Um, how would I kind of just make an actual design for it, get some stuff going on that front. Okay, that makes sense.
Okay.
Cool.
Well, yeah,
Right.
that's about time for us, Robert. Thank you very much for joining today.
Thank you for hosting. I appreciate you doing
No
this.
worries. Take care.